one time. It looked like it had been explored for quite a few years and then dropped until after we proposed this, we see that a paper published with this very same idea. This is classic. This seems to happen to me constantly. Many of you feel this way. So this is one from University of Cyprus, not a group that I'm terribly well connected with, but they published a paper on a system that is really more focused on identifying contaminants in distribution systems rather than necessarily as a commercial. But they're doing a little bit of what we want to do, and so we're trying to learn from what they've come up with. And this is in essence the concept. Theirs is a device that can be used in the home that includes a series of sensors that all incorporates ORP as well as pH. And then is linked to a central point that then communicates with a web-based interface of some sort. And so this is an example of the software that they have used. We're not that far yet, and we're going to create something that's a lot simpler than this, we think. And ultimately, it goes to a web platform that records this information. It's available to the homeowner and to the utility as well, so they can see what's happening out in the distribution system.
Have you talked to Hawk? Because there are some boxes you can put in the distribution system, and I think you can pretty much pick what instruments you put in there, and Hawk will build them for you and send your signals to wherever the heck you want to send them. There are utilities, big utilities that have done this.
Yeah, right, yeah. Right, and you know that's part of what we need to do is communicate a little bit more with the companies that are involved in creating sensors and doing this kind of work. Yeah. What we want to do is work with, you know, we could clearly if it's a product that how can I say this? Hawk hasn't developed this yet as a commercial product. So in other words, you can't go out there and buy this from them. We might be able to convince them to do it.
I'm not so sure that you can't. Are you sure of that?
Yeah, I'm sure that there is not a product like this that Hawk offers.
What, you mean with the software?
With the software, the interface, and something that you can use in a home like this.
Oh, yeah, no, they're
Right,
probably not
water
selling
And
that.
so it might be a good
That's
opportunity
point.
for them, but they haven't done it yet. We might be able to convince them to do it.
So you're trying to develop this to put in somebody's home?
Yes, right, yeah. Point of use.
And I guess I was a little, because what I was hearing kind of out of Cincinnati is they were moving away from just measurable chlorine and into a numbers base like we have in Texas. Is that not, you looking at me?
I mean, like basically what as long as they want to actually have a numeric value.
Yeah.
There's some discussion going on about that. Because of the issues they have, say for our parish, for example. I don't know.
There are multiple states that have already gone to war.
Yeah.
You know, what is, But certainly, I mean, this, I can see this being something useful still. But yeah, I mean, it's the Hawk Sentinel system. The Homeland Security Group.
Right.
I mean, they developed originally Homeland Security kind of concerns 8, 10 years ago, whatever.
Yeah, there's a whole issues on. We did some testing using the Hawk system. We took stuff, we spiked it into the water, spiked less than a gallon over a 15-minute period. The sensors were there, they weren't, we could pick stuff up.
You could or couldn't.
Could.
Yeah,
we picked up less than a 1/10 of a milligram per liter of TOC through the various sensor platforms. We took media broth, the same stuff you used to cook up anthrax with, diluted it. It's like a 1 to 20,000 dilution. We could pick it up. We were looking for it.
Yeah, right.
In the noise, you couldn't find that, and this was an incredibly stable baseline over a short period.
Right.
it's the signal to noise issue, the variability.
Yeah, so that's a different objective though. That's what they're trying to do here. It's not what we're trying to do.
Right.
Where we're trying to create a very low cost set of sensors that can be used, and what we're doing at UMass, not at Nebraska, is to look at specifically chlorine residual, and nothing more than that.
And you're particularly trying to add in the cheap communications component.
Right,
That's
and
really
and that's a part of this, and the communication component, and this is what Prashant Shenoy, who's our computer scientist, is working on, is something a little bit, is certainly beyond me, but it's using either Wi-Fi or cellular networks to transfer the data to probably a web-based platform that is accessible to the homeowner or to the consumer who purchased the device, and with the idea that there would be an opportunity to make it available and discoverable by the utility too, so the utility knows what's happening in at least that one particular location. And so that's the concept. That's why it's not really a treatment technology per se. However, there is the opportunity to combine it with also a point of use electrochemical system, with the idea that if you've got an ORP that can determine the extent of oxidation and extent of disinfection that has occurred, you could, if it's low, you could generate with ambient chloride, depending on the system again, a little bit of free chlorine at that point. And so there are a wide range of different electrochemical systems that we've been looking at as possible alternative technologies or new technologies, part of that program, that include such things as this Magnelli-phase substoichiometric titanium oxide that is highly conductive and produces reactive oxidant species, but also chlorine too. And then boron doped diamonds, which have been around for a long time, and it's another technology. And so we've got a couple of units. This is this is what we call reactive membrane, which is an in-to-out flow system that is electrically conductive and does produce on the surface these oxidants. And so there's this is beyond anything that we had proposed originally to EPA, but it is a possibility and something to keep in mind, that there could be ultimately almost like a little bit of a decentralized treatment that would exist at the point of use or point of entry into a home, that could sense the water quality and in turn have feedback to do some level of oxidative treatment right there. And that is about where I want to end and pass it over to Rebecca. In terms of presentations, we've got some plans, but we're still fairly early on this.
The only plant that I know that uses an ORP is to manage permanganate dosing to remove manganese, and they have it dialed in as a serious science, these guys, and they clean the ORP every day.
That's the first thing.
Yeah, with manganese oxidation and deposition.
They're downstream of the oxidation ahead of the chlorine addition. They're trying to pick up very little manganese and I don't think it's manganese fouling. I think it's any fouling. They find makes it inaccurate.
Yeah, right.
And they're all coupled with DH electrode, and that's usually sometimes it goes bad as well.
Yeah.
Yeah.
The fouling
It's
of
a not a.
DH
Yeah.
electrode.
I think
It's not a
you're
real
right.
user-friendly object, that's what I'm saying. It's a daily effort
Yeah.
to keep it operational in the way that you'd like it to be.
Right. And we've looked at a number of different ORP probes already, and we need to look at some more, but some are much more stable than others, we've discovered.
I've heard that from these guys
Yeah.
because they've tried.
I mean, there's some microfluidics for it.
Right, that's right, and that's part of it too. We've got a group at UMass who's making microelectrodes, and there may be some opportunities there. But yeah, I agree. It's
So you want to put this in a house where we have trouble getting people to take a lead sample properly?
Yeah, it's a consumer, it's not a, it's a,
It's not a
it's a
friendly
product.
kind of idea.
Yeah.
This is not necessarily regulatory as a discussion, this is
Uh-huh.
something that would be, it might be citizen scientists, I'm just kind of brainstorming where the first adoption may be, or
Yeah.
it may be a case of folks who just want that, and there are.
Right. There are
people-
people
People
who-
don't want chlorine at all, so they'll be
Yeah.
happy when they see zero.
Might be, yeah, might be,
Yeah.
might be.
Yeah, we have those.
Yeah, right,
Yeah,
right,
yeah.
right. So there are a lot of people in the United States who are, who are concerned about water quality and want to know more. And
Right, I get that,
Yeah.
I get that, I'm not sure how it fits in here, it's
For
not,
me-
it's not clear to me.
I'm kinda curious from a utility's point of view, if you were to, would the utility be responsible helping install these?
No,
Cause the utility, if they have that information, there's
not the way
possibly
I
no
view it.
residual at one of
Yeah.
their taps,
Yeah.
what does that mean to the utility?
Yeah, I mean, maybe there
Knowing
was
that
something
information now,
Mhm.
tomorrow on the system.
But it's something that
does
has.
that switch you in hot water? Now you have
Depending if
to-
it was before or after the hot
Yeah,
water
it-
tank.
Yeah, well, yeah, I mean, I-
No, yeah, I know, it's.
Yeah, I mean, if it's beyond the meter, it's not
It's not.
something
It's not-
we
it's
can.
not
It's not
something
obviously we can
Right.
look at it.
Right.
Right,
Yeah.
but knowing that, so even if you know that, you don't have to disclose, you don't now have
Right.
to send
So-
out a consumer.
Well, it's,
And
it's how
yeah,
good of a customer service do you wanna do at that point?
Yeah,
Yeah.
Mhm.
it does put us in a bind. Yes, we do
Right.
want to, react to it,
Yeah.
but, to what point? If these were integrated into the water meter side and we had assurance that it was still on our side of the meter, right, then there's something.
But what, I would think you wouldn't want that responsibility, you'd want it to be on the other side of the meter.
If it's on the other side of the meter, we don't have, is there internal backflow?
Right.
Are there treatments?
No responsibility for that.
You don't have the responsibility, and I would have
Right.
thought that's what you would want.
Right,
Not to have
but,
responsibility.
but then we also, we don't have quality control on that either.
Yeah, but it's not your device.
No, I'm
Yeah.
saying quality control on the data.
Yeah.
If we get a signal back, there's no chlorine in someone's house,
Uh-huh.
how do we know what's gone on?
I think you'd have to, yeah, sorry, okay,
We gotta move on.
we've gotta move on,
Rebecca,
sorry,
it's
okay,
gonna-
all right. Rebecca, I'm sorry, if you wanna, you take it from here, sorry.
Hi, Rebecca, it's Pat.